This is chapter 8, 8.1. Here we go. Suppose you have a function y equals to f of x. Let y equals to f of x be a function defined on closed interval a to b. Suppose the derivative of the function over the interval is continuous. Let y prime be a continuous function on this interval, a to b. Then the length of y equals to f of x is denoted by L equals to definite integral a to b square root of 1 plus the derivative raised to the second power dx. Okay, new formula, calculating the length of the arc. So suppose this is your graph, y equals to f of x, and just one piece of this graph bounded between a and b in xy plane. Well, of course, we're not going to use a ruler to calculate the arc length. It doesn't make sense. Should I take a ruler and start measuring this from this? Okay, this is this length, this is this length. So what we're doing instead, we're using the Riemann sum by dividing this guy into small pieces and then using the summation notation as these small lengths on x-axis are getting smaller and smaller. The delta x converts into dx, and we get our proper integral, definite integral a to b of square root of 1 plus y prime raised to the second power dx. Later on in next calc class, we're going to see that we can write L as integral a to b square root of 1 plus y prime, or the derivative dy over dx squared times dx. Then we're going to simplify this radical this way, which is equal to the integral a to b square root of 1 plus dy to the second over dx to the second dx, and this is the integral of dx squared plus dy squared, taking common denominator, and dx squared dx. Later on, we're going to use this formula in parametric calculations. Parametric calculation. So later on, we're going to define a new variable like time. Remember that this is a graph in xy plane. We are following the position of a particle, in each position, you have x and y, and they are following each other, and this is the path of that particle. Later on, you're going to see that we can introduce some new variables like time, why not? And we're connecting the position to the time, and we convert all of these formulas in parametric form. Very well. Suppose you have this guy here. Example. Find the length of what is our function? Y equals to x to 3/2 between these 2 points, 1 and 1, 2, 4, and 8. Very well. So recall that the arc length L is integral a to b square root of 1 plus the derivative of the function raised to second power dx. Okay, very well. So everything is crystal clear. My x is bounded between 1 and 4. 1 and 4. This is my A. This is my B. The initial point, terminal point, and taking the derivative is not that hard. My prime is 3/2 x to 3/2 minus 1, or my prime is 3/2 x to 1/2. Okay. So L is equal to the integral 1 to 4 square root of 1 plus the derivative raised to the second. 3/2 x to 1/2 raised to the second power dx. Okay. L is equal to 1 to 4 square root of 1 plus 9 over 4x dx. Okay. This can be calculated using u sub easily. Like u with a quantity inside the radical 9 over 4x. So du is 9/4 dx, or dx is 4 over 9 du. To change this, so L is equal to the integral square root of u and 4 over 9 du. So this is u to 1/2. This gives me 1 over 1 plus 1/2 u, which is 1 plus 9 over 4x, 1 plus 1/2, and x ranges between 1 to 4. This guy is equal to, so if you take common denominator, you get 2/3, and I missed this guy, 4 over 9. 4 over 9 times 2/3, and then for this guy, we just need to plug in 4, then plug in 1, and try to simplify this. We get 1 plus 9, 10 raised to 3/2, minus, when I plug in 1, I get 13 over 4 raised to 3/2. So eventually we have to use a calculator. You have 8 over 27, 10 to 3 halves minus 13 over 4 raised to 3 halves. Julie needs to use a calculator. This is the length of this. This guy in x line plane 1, 2, 4. So you have 1 and 1. Okay, 4 and 8. And the behavior of this guy is going to be almost like this. So we calculated this length here, which is this ugly number, 8 over 27. Times 10 to 3 halves minus, if we simplify this guy, 13 over 4 to 3 halves. Okay, give us more examples. Well, here's another example for you. Here we have, find the length.